we feel is good for every researcher, every learner in the area of correlation and regression. What is important is we should be always, curious to learn. If you are curious to learn, nobody can stop you to learn. If you are not curious to learn, nobody can motivate you to learn. So everything is in your hand. If you are curious, if you are committed for learning, you will definitely learn the things. And you have to learn with understanding. If you understand, you are confident. If you understand, you can explain it to others in simple words. If you understand, you can communicate it very effectively and efficiently. And therefore, whatever we are learning today, we have to learn it with understanding. And in that, if you have any query, any question, you can put your queries and questions in the chat box. If you wish, you can directly talk to me and make sure that you are understanding the things. Make sure that you are getting clarity of what we are talking about and you are getting understanding of what we are talking about. So friends, let's start our session with focus on research. Whatever one undertakes, he or she has to come out with a research design. Whatever research problems you have before you, you have to design it in a scientific manner so that you can address your research issues in a scientific manner. We cannot imagine a good research without a good research design. And there are different designs for different kinds of problems. It may be quantitative, qualitative, it may be descriptive, causative, and other kinds of design. It may be experimentation, simulation, depending upon what exactly you have an issue before you, you have to design your research accordingly. But you have to have some design. So let's enjoy the snowfall. We have rains outside, but let's enjoy rains. Yeah. And friends, you might be wondering why I'm sharing with you this kind of snowfall video with you. As a researcher, we have a question here. Is it a fall in temperature that causes snowfall, or is it the snowfall that causes temperature to fall? What is that which is, what is cause here? What is effect here? Is it a fall in temperature that is causing snowfall to happen, or is it the snowfall that gets captured that causes temperature to fall? Any one of you, can you try? Any one of you like to respond? Maybe some of you are from hills and they might have seen the snowfall. So what do you think? Is it the sudden fall in the temperature that is causing snowfall, or after the snowfall you find the temperature is falling? Anybody? Friend, this is your program. If you don't participate. Yes, Pallavi, please go ahead.
Sir, I think it is the temperature that causes snowfall, fall in the temperature.
Okay. But we in Delhi, hear a lot of things that Shimla is having snowfall and other surrounding areas are having snowfall, and therefore there is a fall in the temperature of Delhi. Is that right?
Yes, sir, it is right.
So what is that correct view?
So, but in the hills, when the temperature falls, I think then it is the snowfall.
Okay. But we in plains see fall in the temperature when there is a snowfall in Nainital or Shimla or some other place like that.
Yes, sir.
Why this is happening? What is the exact research question if I have to frame? And what kind of research design? The snowfall is a cause for temperature. Need to understand the evaluation process of Earth. Padma Reddy. Snowfall is a cause for temperature. I don't know. Snowfall is causing fall in temperature. Is that Padma is saying? Anyway. If you go to hills, you will find it is the fall in the temperature that causes snowfall. But people who are residing in the plains, they see fall in the temperature when they have snowfalls in the upper ranges and the hills. Why I'm saying it? Because the research questions which we have and the questions which we are going to answer them, they are highly context dependent. And accordingly, you have to make your design, research design. So you cannot have a blanket kind of a issue, which will be always true. Many cases you'll find the cause and effect relationship is dependent upon the context in which we are talking about. So that's what we have to understand when we are designing our research. Don't do it blindly. Do it consciously and see what exactly is the problem before you. Look at another video, lightning and thunder. Is lightning that causes thunder, or is it thunder that causes lightning? What is it? What should be the appropriate research design which we need in this case? We have to understand cause and we have to understand yes, everybody. Is it lightning that causes thunder, or who is Chodlinga? Who is that?
Yes, sir.
Yes, you have raised your hand?
Yes, sir.
Yes, please tell me.
Sir, ಇದು fall of the temperature is the heavy vehicle.
Heavy vehicle?
Heavy vehicle motors polluted.
Yes, anybody? What is cause and what is effect?
Sir, actually, thunder causes lightning, sir.
Are you sure?
Yeah, sir.
What makes you to come out with this conclusion that thunder is causing lightning?
When clouds clash together, then it causes lightning in the sky.
Right, and then thunder comes, right?
Yeah,
So what comes first, lightning or thunder?
but lightning comes first.
Yes,
Lightning comes first, sir, because speed of the light is more than the speed of
right.
sound.
That's what we see. But both the events are happening simultaneously. We observe them with a gap of time, but both the events are happening simultaneously. Okay, what causes lightning? Of course, thunder is not causing lightning. Something else is causing lightning.
Positive and negative clouds, they hit together,
Right.
sir.
You're absolutely right.
Yes, sir.
And, Dr. J.
I'm Nagaveni T, sir,
Yes.
from Mysore.
Okay, welcome.
Thank you, sir.
So many people had said clouds collide. That's true. Positive charge and negatively charged clouds, when they are coming together, then lightning happens and that causes thunder. You might be wondering why I'm throwing all these issues before you. As a researcher, many times we are not very clear what is the cause and what is the effect. And how do we know it? Either the theory will guide us in establishing cause and effect relationship, or we have to develop our own logic and argument to establish cause and effect relationship. But as a researcher, we have to have some kind of cause and effect relationship. Okay. Another question that arises is, do you think everything has a cause and effect, or there are certain phenomena which are showing some kind of association? So for example, if I make a statement, right? As age increases, people tends to become more rich. It has been observed that with the increase in the age, people are becoming more rich. I don't know whether you will be agreeing with this observation or not, but it has been seen that as a person grows, he becomes more rich. Okay? Can I say that age is causing richness of a person? Can I make that statement? There may be some association between them, but can I say age is the cause of richness? Can we make that kind of a statement? There are many, phenomena which are showing some kind of association, but they are not cause and effect relationship. How to capture those association and what should be my research design in that? That's another issue which we have to answer. So we have to understand mystery behind cause and effect. When an event causes another to happen, the cause is why something is happening and effect is what happens. And that establishes cause and effect relationship. As a person becomes older, he becomes rich. That point I've already discussed. With increase in the age of a person, his medical bill start increasing. What is the difference in the research questions like this? How do we see the difference between these two? You have
Sir,
to
as a
appreciate.
as a person
Yes.
gains his age, I mean, as he grows older, his
Right.
experience costs him, sir.
Okay.
As he gains his experience, his salary will also be increased.
Okay.
When we compare to the medical bills, that would be probably after 60s only. So,
Okay. Okay. So,
so
what is causing increase in salary? The experience or the age?
experience, sir.
Huh?
Experience, sir.
Experience. So
Yes.
what you have age, experience,
Yes, sir.
richness.
As person grows old, experiences add up, sir.
Right, but it should be right experience, right? So
Yes,
that
yes, sir. Yes, sir. True.
fetches good salary for you. Okay. And
The statement
Yes.
that statement may not be true always, sir.
right, right.
So we can't find always the positive correlation between these two variables.
Dr. Divya, are you talking
Yes.
about correlation or
Yes, yes.
causal
Cause effect.
relation?
Cause effect. Yes, sir.
There are two.
Yes, sir. Yes. Yes, sir.
Correlation means association. Age is associated with the richness, but age itself is not causing richness. Something else is causing that richness. Maybe your hard work. And it may be possible that with the age you have experience, you work hard, and therefore you get the richness. So cause is something different, but we see association between age and richness. As the person grow older and older, he attracts more different kind of sickness and different kind of illness. And therefore the medical bill of that person may increase. Okay. That means we have to appreciate the proper perspective of the research questions which we have. As Dr. Divya was talking about correlation. So is it correlation we are looking forward, or is it the cause and effect relationship that we are looking for? As a researcher, you have to take it. Nobody else is going to help you. You have to come out with the answer to your research questions. Is it association you are looking forward, or is it the cause and effect you are looking for? Declarative. Yes, sir. Pradamba, right, Pradamba. First statement looks like declarative, but therefore it's not a good research question. Yes, it's a declarative, both are a statement, but as a researcher, you can convert them into research questions. That you can do. What do you think? Which mode of teaching you would like to adopt after the end of the pandemic? Do you think gender has something to do with the preference for online teaching? What is that we are trying to study between them? Can I say gender is causing mode of teaching? I cannot say that. But there may be some association between the gender and the preference for offline teaching, online teaching, and both. Many times, association and cause and effect looks to be, looks to be same, but they are not same, they are different. And as a researcher, you have to think what exactly you want. Are you looking for association? Are you looking for cause and effect relationship? The purpose of this discussion is orient ourselves with the research mindset and learn about correlation and regression. In this session, we are going to consider the following kinds of research. The associative or relational or correlation research and causal research. For this kind of research, the appropriate tool is correlation or measure of association, and to establish cause and effect relationship, the appropriate tool is regression, and that's what we are going to discuss. I hope many of you are pursuing their PhD program. Can any one of you share with me their research questions? Any research question which comes to their mind? Or those who have already done PhD. So during those PhD time, what were the research questions they have in their mind? Anyone would like to share? One or two issues. I don't want many issues. Anyone? Don't hesitate.
Basically, relationships. The relation of pollution with the distribution of algae.
Distribution of?
Algae. Organisms.
Okay.
Distribution of marine organisms.
Organic, right?
Yes. Organism. NAS.
Organism. So in that case, do you think this is cause or association? What is it? That is something as a researcher we have to take a call. And accordingly, we have to proceed in our analysis. Okay? That is something which we have to keep in our mind. Anybody else?
Yes, sir.
Yes, Aina.
Yes, sir. Sir, the effect of microfinance on the social and economic lives of people.
Impact of microfinance on social and economic life of the people, right?
Yes, sir.
Are we looking for cause and effect relationship here, or are we looking for just correlation? What do you think? It's a cause
Yes, sir.
which affects the social life. Microfinance is as an institution may increase the welfare of the people, social as well as the economic. Growth of private schools are perpetuating the Varna system. Okay, so in that case, we have schools are private, public, and we want to see whether they are perpetuating the Varun system or not. Okay. Now, what exactly we want here? Difference in the behavior of the private and public schools. Here, we are not looking for cause and effect relationship. We are looking whether they are different or they are not different as far as the Varun system is concerned. And does sustainable practices help in sustainable tourism development? Yes. practices are the causes that can help in developing sustainable tourism. Yes. So I think many of you have research issues which are involving association, which are involving cause and effect relationship. And there are research issues where neither correlation works nor causative things work. It works something different. Okay, like difference of the mean, for example, there we are not checking anything. Impact of employment programs on the youth. So there is a cause, which is the employment program, and impact on the life of the youth. Right, Dr. Divya. Anyway, so let's go ahead with the correlation. Associative or relational relationship, that's what we are going to discuss, and we're looking for relations among the variables. This term correlation is not a new term for all of you. You must be knowing it. I want to know from you what you people understand by this term correlation, and why we are having this particular session. I mean, correlation is not a great thing. You can just run something and you get a correlation. But what is correlation? How we feel about correlation? What is it? Anyone?
It shows the relation.
It shows
the association or relationship between two or more than two variables.
Simultaneously or individually?
Pardon?
If you have three variables,
yeah,
can you find out the correlation between them?
Yeah, of course, sir.
No. Dr. Divya, please listen to me. Collectively or individually? That means you can you find out correlation between x1, x2 and x3, or x1 and x2, x1 and x3, x2 and x3.
Any two, sir. X1, X2, X1, X3.
Right. So what does it mean? Correlation gives you pairwise relationship. So even if you are having 10 variables, you will get the pairwise correlation between them. Okay. What kind of relation it shows? It shows relationship. What kind of relationship?
Dependency?
No. It shows linear relation.
Positive and negative correlation, sir?
Linear relation.
Okay.
It doesn't capture non-linear relationship between the variables. The correlation which you're talking about, it captures linear relation between the variables. And that linear relationship may be negative. Dr. Anupma, I think, do you think that the sign of the correlation always exists? Is it possible to get always plus and minus sign? Can we think of a situation, Ampurna, right, Anapurna, right. Dr. Anupurna, do you think that there may be a situation where negative correlation can never exist?
Yes, sir.
When?
Actually,
suppose I want to find out, is there any relation between the gender and the preference for the teaching mode? What is
When the
nature of
variables change in opposite directions, sir?
Yes, yes.
Negative
Negative is the
correlation.
opposite direction.
Yes.
Okay. So what is this data? This is nominal. This is also nominal. So if I'm trying to find out a measure of association between the nominal variables, then you will not get a direction. You will get only relation, nothing else. Because nominal variables don't have a direction. They are categorical variables. They just tell you or hints at a particular class or a category. And they will never give you negative relationship. Ordinal data, yes, positive negative relationship exists. Scale level data, positive negative relationship does exist. But nominal data, only the positive relation exists and not the negative. Normally, when we talk about correlation or a measure of association, we talk three things: strength, degree, direction. That means we have three dimensions which are associated with correlation. Degree of correlation, direction of correlation, and strength of correlation. Now you might be wondering, what does it mean? Degree means number. And usually that number lies between -1 and +1. So if I say my correlation is 0.7, that's the degree of correlation. Direction shows positive or negative. Strength. Do we have weak correlation? Do we have moderate correlation? Do we have strong correlation? That talks about the strength of, correlation. So whenever we talk about correlation, we talk in terms of degree, direction, strength. For nominal data, direction doesn't exist. For ordinal data, direction exists. Scale data, direction exists. Otherwise, all the three you will find are normally associated with a measure of correlation. You call it correlation, you call it measure of association, doesn't matter. And that shows mutual relationship. Correlation will not say that X is impacting Y or Y is impacting X. We don't know. No idea. The only thing we say that both are associated with each other. That's it. So friends, let's start with the measure of association for the nominal data. Friends, you must be aware of chi-square. Chi-square is used to determine the association or the relation among the nominal variables. Chi-square is used to test whether the variables under study are independent or not, whether they are having some kind of association or not. But we have a problem with the chi-square. It shows whether relationship exists or not, but it doesn't give the degree of relationship. And it's highly sensitive to sample size. If your sample size increases, your chi-square will increase, but it's not necessary the strength of association increases. So we rule out chi-square as a measure of association for nominal data. But we use chi-square as a measure for developing the other methods. And the other methods are, one of them is called Tremors contingency coefficient. Sorry. Which is defined as phi squared q minus 1, where q is the minimum of number of rows and columns, and phi square is defined as chi squared upon n, the number of observations. Normally, for nominal data, we use contingency coefficient for calculating degrees of efficiency. This gives you degrees of efficiency, which is lying between 0 and 1. And we define its strength in terms of this. If it is between 0 to 10%, negligible association, 10 to 20 weak, 20 to 40 moderate, 40 to 60 fairly strong, and 60 to 99% or 100% is very strong correlation. And friends, please remember, these are just thumb rules, not based on any kind of scientific study, just thumb rules which are used in practice. Okay. So let's take some example of nominal data and say, here research question is outdoor entertainment. The preference for outdoor entertainment has any relation with the gender of the person. Can I say that male looks for this particular kind of games, outdoor games, and female? Or there is no difference? Anyone can have any kind of outdoor entertainment games. And similarly, student, homemaker, salaried, self-employed, single, and married people. Now I want to see whether there is some association between them. And you will find gender is nominal. This is also nominal. And here we can make use of Tremors V, the this is the cross tabulation which we have here. And this is the p-value, which is approximately equal to 0. Null, no relation, is rejected. That means there is some association or relation between the gender and entertainment, outdoor entertainment. What is that? That you can make out from the cross step. Okay, let's have a look at here. Look at this number to appreciate. What does it mean? It clearly shows that male are going for adventurous experience. So they will go for, the games, outdoor games, which are adventurous in nature. On the other hand, if you see the female, 45 female out of 105, they like to go for shopping in malls, and male would like to go for watching movie in a theater, dining with the friends, like this. Now, what does it convey to us what is the policy implication we have for it. Suppose you are an event manager and you have to organize outdoor entertainment events, and you have to look for the male and the female both. So what you will do as a policymaker? As a policymaker for male, you will organize adventurous kind of events, and for female, they would like to go for shopping, etc. So accordingly, you can come out with the policy making. How do we do it in spaces? I show you. And many times, we just apply chi-square for nominal data without caring that we can calculate exact degree of relationship, and we can show that this relationship is stronger as compared to the other one. And I've seen people are wasting their information from the data. They're not fully utilizing it. So let me show you how can you do it. It's simple. So we have the gender and the entertainment, outdoor entertainment. So go to analyze and then descriptive statistics, cross step. So I take gender in rows, entertainment for the genders, and statistics, phi and Tremors V. And that's the result which we get. Simple. No complexity in it. Analyze, cross tabulation, analyze, descriptive, cross step, and whatever you want to see in the row and column, you have to prescribe it, and then you say statistics which you're looking for. If you want percentages, you can calculate row percentage, for example. You get row percentage here. And you can see 34% of the male are going for outdoor, while 42% of the female looks for shopping in malls. Okay, so that's how you can, interpret the results. Okay, this also has a data about the mode and gender. Okay, any one of you, what do you think? Male students prefer offline teaching or female students are preferring online teaching? Which one prefers what kind of teaching mode? So let's see the association between them. So I go back to analyze, descriptive, and I take a mode, analyze, descriptive, and cross tabulation, push them back. Gender in rows and let me Just I just want to take it on a I have to take it as a copy special image. Now, if you see here, what we get. My null hypothesis that there is no association between the gender and the preference for mode of teaching. That null hypothesis is rejected because my p-value is less than 5%. Okay. Now, if there is a difference, where we see the difference? Here we see the difference. As compared to female, male are preferring online mode, and female prefers both as compared to male. So once you get this kind of a conclusion, then you can take a policy decision for the same. I mean, the decision which you get or the hypothesis which you accept or reject, whatever you do it should result into some kind of recommendation or policy decision making. And that is something which you have to look at. Okay, so friends, now I believe whenever you have nominal data with you, you will definitely like to work out with that data some kind of association, and that association you can work out by using Tremors. And SPSS supports that. Okay, for ordinal data, So having discussed about nominal data, let's look at the ordinal data. For ordinal data, if you know, we calculate what is called Spearman rank order correlation. In this case, what we do, the ordinal data is put either in a decreasing order or increasing order. We give them a rank and then we calculate what is called rank order correlation using this particular formula. There is another method of finding out the degree of agreement and disagreement, and that's Goodman-Krukal gamma. And C is the pair of concordance or the pair of agreement. D is pair of disagreement. Say, for example, you have 10 experts, 1, 2, 3, 4, 10, and you are taking their opinion about a particular phenomena, say X phenomena. So what you would like to know, whether their opinions are in agreement or not. And to capture that degree of agreement, you can make use of Goodman-Kruskal gamma. And please understand, measure of association and a measure of agreement, they are not exactly the same. There are some finer differences between them. Correlation. And we're talking about ordinal data. And degree of agreement. For correlation, you can use Spearman rank correlation. And for degree of agreement, you can use that Goodman-Kruskal gamma. And please appreciate there's a difference between correlation and degree of agreement. If you are asking opinion of the respondent, a particular aspect, say for example, you are asking whether you would like to invest in equity shares or not. Okay, so different people will give you different, opinion about that investment regarding equity. So what is the degree of agreement among the respondents related to the investment in equity? That degree of agreement you can calculate by using Goodman-Kruskal gamma. Please understand this. And you prefer that your life partner's family should be financially sound. Love marriage is better than arranged marriage. And that's the cross tabulation which we get. And that's what we get. Gamma, less than 5%. Null hypothesis will be rejected. That means those who are saying that love marriage is better than arranged marriage, they have different preference for the partner's life, family life, partner's family financial position. It's negative. What does it mean? Strongly agree, increasing it. And then this is decreasing. Negative relationship. That means those who believe that love marriage is better than arranged marriage, they prefer that your life partner's family should be financially sound. They strongly agree with it. And that's what
participants are requested to please be on mute.
And finally, the measure of association for the scale data. This is something which is normally understood, okay, when we talk about correlation. And that's called Pearson's correlation coefficient. That's used for scale data. So if it is between 90 to 1% positive, negative both, very strong association, 7 to 90, fairly strong, 40 to 70 moderate, 20 to 40 weak, less than 20 negligible. And friends, please remember, this is only some kind of guidance which based on thumbs up rule and has no scientific backing after. You may use your own way of interpreting the value of the correlation coefficient. So, degree of the student, the BBA, DBA, MBA, and their major in a particular area like accounting and finance, do you see any association between them? Nominal. This is also nominal. So if your data is nominal, then what method we use? Tremors. That you can use. I will come back to the data of it. Rating. What kind of data is it? Rating. Nominal, ordinal, scale. Nominal, ordinal, scale. Think. Why? I said in the beginning, you should have a lot of energy. I don't know where that energy has gone. Anyone? Amir, Saloni, you can also answer.
Definitely, sir. Good evening, sir. Namaste. Sorry, मैं disturb नहीं कर रही थी session, sir.
Okay, no problem. What kind of data is it? Anyone?
Sir, ordinal?
Yes, ordinal. What about this? Because you can put them in some kind of an order. AAA is having more safety as compared to AA. So there is a hierarchy, there is an order. So ordinal data. And public response, oversubscribed, fully subscribed, undersubscribed, that is also ordinal data. So we have ordinal versus ordinal. There you can make use of gamma. And I show you how can we do it. Process is same. Go to analyze, descriptive, cross-tabulation, and in that you select statistics and pick the data. Pick the appropriate test. Let me check. It's a different file. Right. What is the role of frequency? Anyone? What frequency represents?
Occurrence of an event, sir.
Right. So how should we treat it here? How should we treat it? How should we? How should we treat it? It's a frequency, right? That means this combination, BPA and accounting, is occurring 78 times. Okay, that means it's a weight. And SPSS says that if you are having frequency, then it should be declared as a weight. So I have two weight cases by the frequency variable, which is this one. And once the weights are on, okay, they will be always on, and you can, whatever further processing you do, it will be, all the processing will be weighted according to the frequency. If you want to switch it off, so to go to data again, weight cases, you simply say don't weight cases, okay. And then you will find the sign of the weight is not there. You see here. The sign of the weight is not there. If you declare that frequencies are your weight, then you will find weight on symbol here. Okay, so now I go to analyze, descriptive, cross step, decrease rows, major columns, statistics. It's a or nominal, so it suggests phi and Tremors. And that's the result. What does it mean? What does it indicate? BBA people go for accounting and finance, majority. MBA people are going for others in majority cases. And the DBA, the diploma in the business administration people, they are also going for others. But BBA people are going primarily for accounting and finance, that you can declare. So there is a clear-cut preference by the students, and you can know about them. Let me take one more example and now here we have a very interesting case. We have beta of a company and the size of a company, and there are two sizes of a company, big company and a small company. You see here, small and big. Size, small and big. And beta of a company. Who is from finance background? Who talk? Who talked about microfinance? Who is there from finance background?
Yes, sir. I was there.
Yes, Aina, right. Aina, what is
Yes.
beta? What is
Sir,
beta? What is it? It is a
I
measure
don't
of
know. I
Aina,
don't know, sir.
Aina. If a finance person say I doesn't know beta, this is something which is not acceptable.
Hmm.
Beta is a measure of risk,
Risk.
systematic risk. So we want to see whether there is some relation between the size of a company and the risk of a company. Are small companies are risky or the big companies are risky? So we have dichotomous variable here having 0 and 1 values, and we have a scale level variable here. What to do in such a case? I hope you understand the problem. On one side, you have binary variable, and on the other side, you have a scale level variable, and you want to establish relation between them. How do we do it? Anyone? Can you think how we can do it? In fact, I have not discussed about it, but we can do it. If I take statistics here, do you see this? Eta is a nominal by interval. So you have a nominal data on one side and the interval data on the other side. Okay, there is another option which you can find, I think, in correlation. No. Analyze descriptive. Sorry. Analyze descriptive cross step. I take beta in the rows and this in the column. Statistics is my eta. So the value is coming to be 1 point. Beta dependent and 0.155 size of the company on the basis of market capitalization dependent variable, then 6.56. What does it mean? What does it mean? Higher the value of the eta, higher the degree of the correlation between them. So beta, if I can work with it. Beta is a function of size. The relationship is coming to be 1.155, and size of the company on the basis of the market dependent variable. Size is a function of beta 0.656. So logically, size does not depend upon beta, that we ignore. So we have to consider this value. And that's 0.155. So there is no very strong relationship between the size of the company and the beta of the company. That's what it says. And that's how you can interpret the results. Right.
All participants, please be on mute.
ನಾಳೆ ಕೊಡ್ತಾವ ನಾಳೆ ನಾಡ್ದು ಸೋಮವಾರದಿಂದ
Nitu ma'am, Meena ma'am, please be on mute.
वही वही 5 दिन का है ना हमें टाइम रहता है लेकिन 9 दिवस दिन नाले मंडे ಕೊಡ್ತಾವ
Right. That's how we get this relationship between them. And if you believe that size is a ordinal data, you can make use of ordinal and ordinal. You can make use of a gamma and you can get the relationship. Negative and 0.004. So that means it shows that the small companies are more risky as compared to the large companies because 0 is small, 1 is, big. So higher the number, lower is the barely the beta, that's what it says, negative relationship. And that negative relationship is coming to be negative. Here I'm assuming that my size, small and big, they are having some order. So I'm taking them as ordinal number and I'm calculating gamma here. And we can also calculate a simple correlation between the files and simple correlation is easy. All of you are doing it. So say what is the relation between the midterm examination marks and the final term examination mark? Both are scale level, so you can make use of the Pearson's correlation. So go to correlate by variate and midterm exam and the short final exam, Pearson's correlation. And that's what it is. 0.781, significant. That means what? Those who are getting higher marks in the midterm, they are probably going to get higher marks in the end. There is a very high positive correlation between them. So motivate the student to do well in the midterm. If they do well in the midterm, they will definitely get good marks in the end. Okay? Like workers stay in the organization, it's ordinal by ordinal. You can go for gamma in this particular case. And midterm marks and the short-term marks that you can see. And there is a relation between them, and that's a positive relationship between this. So how many hours of average do you sleep during night? And are you able to retain the content taught during the lectures in the percentage? This is ordinal. This is ordinal. And you can make use of gamma for that purpose. I have this data with me. I think I have opened this particular file. Yes, sleep hours in the night and effect of sleep hours on the retention rate. So I go to analyze, descriptive, cross-step. Statistics is by gamma. And that's the result which we get. 0.83. Null is not rejected. My null was there is no relation between the sleep hours in the night and the retention rate in the classes during the daytime. That's what we get here. So I hope, friends, you are able to understand the idea of the correlation. And one important thing about correlation, which we have to understand, is correlation is square, which is called R square. That means there is association between X and Y, assuming they are scale level variable. If you have the correlation between R, if you take a square of it, we get what is called R square. Higher the R square, that means the power of explanation is high. So I can, if I'm dealing with one as cause and another with effect, you will find that there will be high degree of R square between them. So degree of explanation, the size of the explanation, you can find out by calculating what is called R square. R square tells how much of the total variation can be explained by the other variable. That's what you can get through R square. Okay, so friend, let me summarize quickly. Correlation is a measure of linear relation. If correlation is zero, it doesn't mean that they are not related. They are related. They may be related in a non-linear fashion. But the correlation which we have talked today in this particular session, that's a linear relationship. We understand correlation on 3 dimensions. The degree of correlation, the direction of the correlation, and strength of the correlation. Then we discuss about nominal data, just a minute. Nominal data, we use Tremors V, and ordinal data, we use Spearman correlation or gamma, and for the scale level data, we use Pearson's correlation. And this correlation measure is used where we are having, relational research problem or associative research problems. So after this discussion, friends, I trust that you understand the challenges of associative or correlational research. Any question, you're most welcome. Any question, any doubt, if you have. Anyone having any question, please don't hesitate. No? So friends, I think let's take a 5 minutes break, and after the break, we will come back and discuss other part of our agenda. Okay?
Yes, sir. All participants are requested to be here back at 6:40 sharp. Yes, sir. We can.
Should we start?
Yes.
Okay. So friends, before we proceed further, a quote for all of us: what we learn with pleasure, we never forget. The fact you people are here in this evening, I believe that all of you are finding pleasure in learning. And if you are finding pleasure in learning, you are likely not to forget what you are learning today. So please enjoy and get pleasure, and you will get wonderful learning in this particular session. So what is the best statistical tool for causal research? That is regression analysis. We have other tools as well, but the best one I'm saying is the regression one. Okay, so two kinds of research design we have seen: associative or relational. There you can make use of correlation, and the causal, there we are going to make use of regression. And friends, regression is a term which is not a new to all of you. Anyone having any specific query about regression, please let me know. I will discuss that in detail. Please don't hesitate. It's your session. It's your program. And you have to learn. If you have any query, any question, please don't hesitate. Aina, do you have any question about regression? If you are doing regression, do you face any problem in that? Anyone? No? Nobody has a problem. Good. Okay. Anyway, so let's touch our agenda for the regression. Regression analysis is an analysis where one of the variable, which is typically taken as y, dependent, and we say it's a function of a number of independent variables, x1, x2. So the practice is y is used to represent dependent variable, while x's are used to represent independent variables. And it is concerned with the study of dependence of one variable and on one or more explanatory variables or independent variables with a view to estimate or predict the population mean or average value of the former in terms of the known or fixed values of the latter. You might be finding some complexity about the regression. Don't worry about it. As you proceed further, I will explain what exactly it means. But do keep in your mind certain things. Predicting or estimating mean or average value of the dependent variable in terms of known or fixed value of the latter, that is the explanatory variable. So it's a causal relationship. You have a number of independent variables and they are impacting your dependent variable, and that's how you can show it through a graph or a chart or a path. The classical model has this kind of a format. We have y, which is equal to alpha plus beta x plus error term. It's classical linear regression model where we are assuming there are two variables, one y dependent, one x independent variable. Alpha is my intercept, beta is my slope parameter, and epsilon is my error term or disturbance term or the noise term. Okay? Error term behaves in a stochastic manner, and therefore the model is called stochastic model or probabilistic model. So whenever we write the equation y is equal to alpha plus beta x plus error term, we observe and we assume, in fact, that this error term, which we have in the model, it has no systematic pattern, purely random. What value it will take, I cannot predict. And therefore, behavior of this error term is random, also called stochastic. And since my error term is stochastic, my y is also become random and stochastic, and the whole model becomes stochastic model. It's not deterministic. This is probabilistic. You cannot determine the exact value of y. You can determine the average or the mean value of y. Okay? And error term takes care of what is called other things being constant, or ceteris paribus. So whatever is not there in the model, that will sit, in the error term. Why do we have disturbance error term? Anyone? Quick. Dr. Divya, Aina, Pallavi, Amir, Saloni, anyone try? Why do we have error term in our model? Why this? Think.
So there are always other factors that we are not aware of, or there's certain.
That's one reason. Any other reason? So only that is one reason, important reason, no doubt about it. What is the reason? Yes, anybody else? Dr. Rachna, would you like to say something?
So can it be that there always be a deviation, like we can't fully predict, or
But why we cannot?
Some kind of difference between the values?
Why can't we predict? What's the problem?
Because sir, the model is a theoretical model. In reality, there always be a difference in the situation.
Right, because of other factors. That's one reason, right? Another reason could be specification error.
Yes.
Not properly specified your model. If you are not properly specifying your model, then you will get error term. We are fitting a linear model, but suppose the relationship is this, and I fit a linear model, then the deviations will definitely happen. Measurement error could be another reason because of the error term. And human indeterminacy, the stochastic nature of the relationship among the variables. So there may be a number of reasons because of which error term does exist. And as Saloni is rightly saying, model which you build, they are theoretical, but reality, the ground reality will be different from those theoretical models. And because of that difference will be reflected in the error term. That difference may be because of the omission of the variables, maybe because of the nonlinearity relations, because of the specification error, measurement error, or inherent indeterminacy of the relationship. Okay? Right, so it's a model, so we are making assumptions about the models. Okay, quick. Who will give me the assumptions? Quick. I mean, participants are behaving as if they are hearing about regression for the first time. I'm sure many of you must have heard about regressions many times. Might be some of you are teaching regression. Might be, I don't know. Okay, so we are assuming that on an average, the error term is going to have a zero value. So some might be positive, some might be negative, but the mean of the error term is zero. That's what we are assuming. We are assuming that variance of the error term is constant for all observations, and that assumption is called homoscedasticity assumption. We are also assuming that error terms are not correlated with each other. Correlation between them is zero. Covariance between them is zero. We are also assuming that X and the error term are not correlated with each other. We are assuming that error term follows normal probability distribution. you will find most of the assumptions are about error term. And we are assuming that x's are given to us. We know them. They are not probabilistic in nature. They are non-stochastic in nature. That's what we are assuming. Okay, so what we estimate expected value of y given x. And now you can recall my definition of regression. That says we estimate average or the mean value of my dependent variable for given values of x. Right? Most of the assumptions are on the error term because error term behaves in a very random manner and there is a need to discipline that error term. And therefore, most of the assumptions are about error term. Okay, so I hope these assumptions are clear and they play a very, very important role in regression. Anyone having any question about assumptions? Please don't hesitate. It's your program. And once the model is defined, assumption is defined, then the next challenge is how to estimate the values of the parameters, that is, how to get an estimate of alpha and beta. And for that, we look for best estimator of alpha and beta. And there are broadly two methods which are used. That is OLS or ordinary least square method. And second method is maximum likelihood method or MLE method. But we will concentrate on OLS or ordinary least square method. Least square method. The square of what? Saloni square of what? Which would like to minimize? The square of the error. So we want to fit best line, and that best is defined in terms of one which minimizes my square of the error. And therefore this method is called least square method or OLS, ordinary least square method. Because in econometrics you will find we have weighted average weighted average least square method, generalized least square method. But the one which I'm going to talk about is ordinary simple OLS. And the simple OLS gives me blue estimates. Best linear unbiased estimators. So y is equal to alpha plus beta x plus error term. We get the values of alpha and beta by using OLS. Sorry. I think just a minute. So we have y. I don't know why it's not working. Right, it's working. So we have y is equal to alpha plus beta x plus error term. We get the estimates of alpha and beta by using OLS. Alpha head and the beta head, they are the estimators. So in econometrics, that's a very generic practice that the estimates which we get, we show them by putting head on them. So alpha head, beta head is my estimates, and they are blue estimates. Best. And they are best because they are having the minimum variance. L for linear, they give the linear relationship, and they give me the unbiased estimators. And therefore, they are called best linear unbiased estimators. So they are linear, unbiased, efficient, consistent, and sufficient estimators. And that's what makes OLS the best estimators. Linear, simple, unbiased, no biasness in them. They are efficient, they have the minimum error term or the minimum variance, and they're consistent. So as you increase the sample size, they tend towards population, and they are sufficient. They are making use of all available information. Okay. Now let's look at statistical properties of OLS estimates and Y and the error term. Okay. I really don't know whether you people are understanding what I'm talking about. Assumptions, OLS, interpretation, why they are best, like that. I hope all of you are getting it. So once we get the estimates, we must understand their properties, especially their statistical properties. So let's start with their statistical properties of estimates, Y, and others. Alpha head, beta head, the estimators of alpha, beta, they follow normal probability distribution. And they are unbiased, so their expected values equal to population parameter alpha and beta, and that's their variances. And if you take the square root of it, you get their standard error. Okay, so please keep in mind that OLS estimators follow normal probability distribution with mean equal to population parameter and variance given by these formulas. Error term, by assumption, follows normal probability distribution, has a zero mean, the expected value of the error term is 0, and variance is constant. And since error term follows normal probability distribution, Y is also following normal probability distribution. And the mean value of Y is alpha head plus beta head X bar. And the variance of the error term is nothing but the variance of the dependent variable Y is equal to the variance of the error term. So variance of Y is equal to variance of error term. And variance of the mean of the error term is 0, variance is S squared, and that's how we calculate the variance of the error term. Okay, so let me summarize up. We have Y is equal to alpha plus beta X. That's my model. and we have made certain assumptions about the model. Then we estimate alpha and beta by making use of OLS or by making use of ordinary least square method. And OLS gives me the best results, and that's why they are called blue estimates. Then we discuss about the properties of alpha hat, beta hat. Both follows normal probability distribution. Y also follow normal probability distribution. Error term also follows normal probability distribution. And since they are following normal probability distribution, our journey regarding hypothesis testing becomes easier because we can make use of T statistics, F statistics, and other statistics. So now we have understood the estimation procedure, OLS, and properties of our estimate of the regression. Any question, friends, before we go ahead? Once we understood all this, then we will go for how to use software to come out with the results. But anyone, any questions? No? So let's see what steps one has to undertake while processing and analyzing the data for regression purposes. First, you have to understand your data summarized through graphs and tables. Whenever you have data in your hand, friends, the very first thing you must do is understand your data. Become friendly with your data. And for that, make graphs, charts, tables, and all that, and try to get feel of your data. Unless and until you understand your data, you cannot do good analysis of your data. Then you have to make a model and get the results of the model, and then testing the model, and we do what is called post-estimation analysis, and finally we report the results. These are the steps which are involved in the analysis of my data when we talk about regression. So friends, let's apply whatever we have learned so far, and we will do first regression by using Excel. And how do we do it? I show you. Let me close these files. I opened so many files, so I'm just closing them. Give me a minute, friends. I'm just closing my different open files. Yes. So let me take regression. So we have the stuff and the waiting time of this stuff in terms of minutes. Right? So how do we do it? we go to data. In data, you will find an option, data analysis. And friends, my request to all of you is please open your Excel and tell me, do you have this option in your Excel or not? Do it quickly. Do you have this option in your Excel? Data and data analysis. Anyone is not able to see this option, data analysis? Let me know.
I have data, but not data analysis.
Hello? Hello?
Sir, I have the option data, but not data analysis.
Pallavi, I suggest what you do, you go to file, follow what I'm doing. Go to file, there you will find options. And the moment you click options, you will get option of add-ins. Click on add-ins. Then at the bottom, you will find Excel add-ins. Then you say go. Then you click this analysis toolpack, VBA, etc. Then you say okay. It will take 1 or 2 seconds. And after that, you will see this option, data analysis. And it's a very, very powerful utility. You can do a lot of statistical work by using this utility of data analysis. Did you get that?
I'm trying.
So data analysis, all the options are arranged in alphabetical order. So I look for regression. And it's asking me the Y range. Y is my waiting time. And start.
So can you repeat the order of how to go for this data analysis? Can you please repeat it?
Okay. Just a minute. You want to see the data analysis option? How do we get? File, options, add-ins. Then at the bottom, we have Excel add-ins, go. And you click and then you say, okay. Saloni has written the sequence of the command.
Yes, I've got it. Thank you very much, sir.
Okay.
I'm Jayaprada.
Yes,
I'm Dr. Jayaprada.
And that's how we get when you go for data analysis, you will find a regression option, and then it will ask for Y and it will ask for X.
Okay. Thank you, sir.
Okay. Right. Yes. That's the output which we get. Okay. So let's see what we can do with this, and please follow me, because many times we find a lot of difficulty in interpreting the results. First, why this is happening. Right. I have to show the model. My model is that waiting time is equal to alpha plus beta staff plus error term. That's my model. What is my estimated model? And in this estimated model, what you will observe, this is your alpha, the intercept. This is your beta, the coefficient. So my model is waiting time is equal to 17.005. I'm taking only 3 digits plus, minus 0.5536 stop. That's my estimated model. Okay. Now, I would like to know from you people what you would like to infer from this particular output. What is that we would like to know? If you have questions in your mind, you can answer them. If you have nothing in your mind, you cannot do anything. So please have questions which we would like to answer. You have the data before you, you have the result before you, you have the output of the regression. What is that you would like to understand? That is something which you have to do. Anyone? I define null hypothesis, alpha is equal to 0. Second hypothesis is beta is equal to 0. Intercept is equal to 0, beta is equal to 0. For that, we look for T and P. So 8e minus 16. What is it? Anybody? What is it? 8e to the power minus 10. This is 8 into 10 to the power minus 16, which is approximately equal to 0. This is also approximately equal to 0. What does it mean? My probability value is coming lower than 5%. My null is rejected. Both the null is rejected. What is the implication of it? What is the implication of it? Intercept is significantly different from 17, from 0. That means even if your staff is 0, still there might be some waiting time of the production function of the machinery. Okay, many times intercept has no interpretation, no meaning for our purposes. What is more important is beta. Beta is not equal to 0, that means there is a relationship. And the sign is negative, that means there is a negative relationship. Larger the number of staff, lower will be the waiting time. That's what we get as a relationship. So beta not equal to 0 implies that y is a function of x true. Y is related with x or x is causing y. Positive sign will indicate a positive relationship. Negative sign will indicate negative relationship. Okay, another thing which we have to look at. What is the interpretation of it? What does it mean? It's a slope. What does it mean? So many names I'm seeing: Jayaprada, Aina, Annapurna, Varsha, Navnath, Kalyan, Swarnan. Yes.
Alpha.
Why don't you answer? Why don't you interact?
Alpha.
Hello?
Alpha.
Alpha is intercept. So if x is 0, y will get this particular value. That's the interpretation of alpha. So if you have 0 stop, still there will be some waiting time that's equal to 17.005. That's what it means. Does it make a sense or not? That you have to take a call depending upon your problem. Okay. What is the interpretation of this slope? 0. minus 0.5536. What does it mean? Yes, Vikram.
Sir, it's a negative correlation. It's a negative
relationship. That's true.
Yes, sir.
But what this 0.5536 represents? Yes, Vikram. It means that if I increase my staff strength by 1%, that is, if I increase it from 10 to 11, my waiting time will be reduced by 0.5536. That's how it means. The slope is nothing but delta y over delta x. That's equal to minus 0.5536. Right? What does it mean? 1 unit change in x will cause minus 0.5536 change in y. That's how we interpret this. Okay. So we understood this, These are the standard errors on the basis of which t values are calculated. These are the p values on the basis of which we take decisions about this hypothesis. So we are able to understand this part of the output. Now let's move to this part of the output. Starting with the simple 40. 40 is the number of observations in my data. Okay, multiple R. R stands for correlation. Correlation between what? This is correlation between Y and predicted Y. You can note down these interpretations for your purpose. Multiple R is nothing but correlation between Y and predicted Y. Then, what is R square? R square is nothing but a square of the correlation. And I can show you if I take the square of this correlation, I get R square. Friends, can you recall R square, which I explained before the break? What does it represent? What R square represents?
It represents variance.
It represents what? Yes, Vikramji. It represents what?
Sir, it is variance.
Variance of what? Variance of what?
Sorry, sir, that I cannot say.
Okay. I give the interpretation. R square represents variation in Y, which is explained by X. Variation in Y, which is explained by X, that is called R square. So we know that there is a variation in Y. Some of the variation can be explained by X. Some of the variation is not explained, and that unexplained part goes to my error term. This is unexplained. This is explained. How much is explained? That is given by R square. So in this case, what does it mean? 44.76%. Now listen carefully what I'm saying. If Y is having a variation of 100, out of that 100, 44.76 variation is explained by X. Remaining is unexplained, and that unexplained part is residing in my error. That's how we interpret R square. That part of Y variation, which is explained by X. And adjusted R square, that I will discuss tomorrow with you when we go for multiple regression, and sorry, day after tomorrow. And the standard error is nothing but, this standard error.
Standard deviation upon root of n.
Standard deviation of what?
Standard deviation upon root n.
No, but it is standard deviation of what? Y, X, or error term?
Error term.
Yes. You're right. Standard error here represents the standard deviation of the error. Okay. And the formula which you are suggesting, that's how we calculate. And we don't use n in the denominator. We use degrees of freedom. And that degrees of freedom depends upon your independent variables. Okay.
Yes, sir.
Now let's move to the next part of the output, which is again important. Jayaprada, can you know what is the degree of the freedom in our model? 40 observations.
It is 40.
What is the number of
39.
observations? 39 is my total.
38 should be so.
39 is my total. Regression is having 2 parameters. Alpha and
38
beta.
it should be.
No. 39 total. Out of this total, regression is having 1 because I have 1 independent variable, and 38 is of the residual, the error term. So when I'm calculating a standard error of the error term, my degree of freedom will be 38. So it will be divided by 38.
Okay.
Right? What is SS? SS is nothing but sum of squares
Sum of squares.
of deviations. A deviation of y. This is the total deviation of y. Total deviation of y. Out of it, this much is explained by the regression. That means if I divide the regression variance by the total, can you imagine what I will get? Anybody guess what I will get? Out of total, how much is explained by the regression? What I will get?
Residual will get
R square. Because R square gives you what? Total explanation by regression module of the total variation.
Okay.
So you will find this is exactly same as your R square. So now you can appreciate better what is R square. Out of the total variation in Y, how much is explained by regression model or X. And when I divide by degrees of freedom, I get mean sum of a square. MS is nothing but mean sum of a square. M stands for mean. So divided by 1, it comes as it is. Divided by 38, if I put it here, this divided by 38, that's what we get, 18.18. Okay, so sum of square of the error term divided by degrees of freedom, what we get? Variance of error term. And if I take the square root of it, what you will get? If I take the square root of it, what I will get? Anybody, any guess? Quick. Hurry up.
Can be standard error.
Yes, absolutely right. Same. Now you can see, you visualize what exactly we are going. And the regression divided by regression means sum square divided by the residual, we get F, and that tells the variation explained the significant amount. F. What is null hypothesis of F? Saloni, can you try? What is null hypothesis of F? variation explained is not significant. And rejection of it means whatever variation is explained by the regression model is a significant. That's what it means. Okay, so friends, this is the table before us. I've tried to explain each and every figure of this table. If you have any query about any number, please let me know. Because understanding output, interpreting it properly, makes a lot of sense, and that's required.
Sir, I would like to know about this confidence interval, lower 95% and upper 95%.
Right.
Their role in the interpretation of this data.
Actually, we don't need it, but if you want to calculate it, you can calculate it. 75, sorry, coefficient value is 17.005 plus minus, corresponding to 95% level. I have to take the value of the t. Because follow t distribution, value of the t corresponding to 95% multiplied by standard error, which is 1.281. And the interpretation of the confidence interval is the population parameter will fall in this particular range. Okay, and see here, so we are 95% confident that the population parameter will fall in this particular range. That's my confidence interval. That's how we get it. And there is a problem with the Excel because it repeats the same output again. And I don't know why it does so. We don't know.
Yeah, thank you, sir.
Okay. Anybody else? Please understand it, because we will not get time again to come back and discuss it. Whether Excel you are using or any software you're using, output comes by and large in the same manner, but the way they are representing, that may be different. But you will get all information that's given here. More questions? Okay. I think let me take one more question hurriedly so that we can refresh. So we have the sales and advertising data. Price I'm ignoring for the time being. So what we do, we go to data, data analysis. Then regression. My Y is sales. And my X is advertisement. First row is having labels, so I click on the labels and I'm looking for new worksheet. And that's what we get as a result. And that's the result we get. So my model is no. Sales is equal to alpha plus beta advertisement plus error term. This is my model. Estimated model is sales is equal to, what is the value of the intercept? Please tell me from this, what is the value of the intercept? Quick. What is the value of the intercept? 74.179. What is the value of the beta?
1.73.
1.7326. The interpretation of this is that even if your advertisement expense is 0, you will get sales of 74.179. That's the interpretation of the alpha, beta. If you increase your advertising spending by 1 unit, my sales will increase by 1.7326, which is good. By spending 1 rupee, if you can increase your sales by 1.736, that's a good effect of the advertisement. Okay? Then look at this. Values. Alpha is significant and beta is also significant as p values are almost 0. And if I say beta is significant, that means there is a significant positive relation between advertisement and sales. Policy implication is that if a firm wants to push its sales, they can increase their spending on advertisement. And R square is this much. This is my R square. Sorry. This is my R square, which is very low. 5% change in sales is explained by advertisement, and large is to be explained by, advertisement p-value is more than 5%, is not coming to be significant. So that shows advertisement is not having significant impact on the sales. That's what it is. And R square is 5%, not much. Standard error is this, and F is also not coming to be significant, that shows up there is insignificant explanation of change in sales by advertisement. That's what it is. Okay, is that clear? Any question here? No? Okay. So let's go ahead. We can do regression in Excel comfortably and quickly by using data analysis, utility of the Excel, and if you do not see this data utility of data analysis, you can add it by seeing the following video, which I am skipping. And once you have installed it, you can do the regression. And we have also seen how to interpret the results. Before we proceed further, let's address two very, very important issues. One, how to report the results. This is the result which we get. So anyone, how do we interpret the results? If I have to report my result, how should I report my result? That's one question I must answer. So many people I've seen, even in the research article, what they do, they took out the complete output and pasted. But that's not good practice. Pick up only relevant information from the output table and report it. And what is that essential and important piece of information which we have to report? First, you have to report the underlying theory, which is helping you to come out with the model. Then you have to write the testable model. Give me a minute. I don't know why it's not working. Yes. So in our example, we say that it is believed that if a company is incurring expenditure on advertisement, it leads to increase in sales. So we have some underlying logic that establishes the cause and effect relationship between advertisement and the sales. My testable model is sales. I don't know why it's not working. Just give me a minute. So sales is equal to alpha plus beta advertisement plus error term. This is my testable model. Sample size is 75. Estimated regression equation is sales is equal to 74.179 and 1.727326. This is my estimable estimated regression equation. Then below A, you must report the standard errors of the same. 1.79, 0.89. No need to report the t-values and the probability values because a reader who has values of alpha and its associated standard error, they can calculate, the t-values and the associated p-values. You have to simply say that this is coming to be significant or this is not coming to be significant. And then you can report standard error or R square in your model. That's the only thing you are supposed to report. It's not nice and required that you take the whole output and paste it in your research article. Please don't do that. Take only that information which is relevant. What is that relevant? This is the relevant information which we see. Second thing is that's how we report it. This is your testable model. This is estimated model. These are the standard errors of your estimates. This is R squared. This is sample size. How do we know whether our regression model is a good model or a bad model? You have y is equal to alpha plus beta x plus error term. We have estimated using OLS. We got the estimated model. How do we know it's a good model? Yes, quick, tell me. What is that I should look at in my output table to understand that the results which we get, they are the good results? Quick, hurry up. How do we know? What is that in this table I should look at in order to get that my model is a good model, my estimates are good estimates? Anyone? Jayaprada, can you try? Divya?
Sir, can it be F value?
Yes. What else?
And significance.
Significant, yes. What else? You are missing very important indicator. R is
degrees of freedom.
R is degrees of freedom doesn't say anything.
Okay, R square.
About the sample size. Larger the sample size, larger the degrees of freedom.
Okay.
R is square.
R square. Okay.
Standard error.
Okay.
Okay. Higher the R is square, higher the explanatory power, model is a good model. Higher standard error of the error term.
Bad model.
It's not a good model, it's a bad model.
That's what bad model.
Higher the value of F.
Bad model.
Square. Goodness of it. Higher it is, better it is. The standard error of regression, lower it is, better it is. And F value from ANOVA. Significant, good. Not significant, not good. And the significance of the coefficients, the p-values, which are there. High R is square, lower standard error, significant F, significant alpha, significant beta makes my module a good model.
Okay.
So when you report whether your model is a good model or not, you can report all this. And if they are looked to be better, that means your model is a good model. Any questions if any one of you have? Please don't hesitate. This is the time when we can interact and we can make our concepts clear. And that's the purpose of the workshop. No questions? Okay. So friend, that's all from my side today. And Monday, we'll be talking about multiple regression and the complications which are arising because of multiple regression. So that's all I want to discuss with you this evening. Thank you very much for being with me. Thanks a lot. Enjoy. Have a good time.
Thank you, sir.
Thank you.
Deliver the official vote of thanks, sir. It gives me immense pleasure to deliver the vote of thanks for this session. I would like to express my heartfelt thanks to Professor Gupta sir for such an enriching session. So the way you've explained regression, correlation analysis, along with all the tests that have to be used in such a simple way, such a humble way. So we're very thankful to you for that. And we're really looking forward for Monday's session also, so that we can dive deep into our knowledge systems. Thank you so much.
Thank you. Thanks a lot. Thanks everyone. Have a good time.
All participants are requested to join on Monday sharp at 5 p.m.
Hello. Hello.
Yes. Yes, ma'am.
Excuse me, ma'am. Just a query. Ma'am, day before yesterday, we are supposed to upload the assignment, but we are getting the button is not at all visible. It is a problem from the technical side, or what we are supposed to do? Should we wait for the next 1 or 2 days?
Ma'am, we'll just check it at our technical end and we'll get back to you. The information will be conveyed to you over our Telegram group.
Okay, ma'am. The thing was today was the last day to submit, and that's the reason,
And we'll just check it and get back to you.
Yes, ma'am. Yes, ma'am. Thank you. Nice session, ma'am. Thank you.
Thank you so much.
Thank you.
Thank you.
Very nice session. Thank you, sir.
Thank you.
Thank
Thank you very much.
you, sir.
Thank you.